Okay, in this question we have to find out Nyquist sampling rate. So Nyquist sampling rate is nothing but Fs is equal to 2 into maximum frequency content of signal, maximum frequency content of xt. Suppose you have to sample a continuous time signal xt, you have to do sampling of xt. So the Nyquist sampling rate for xt will be 2 into the maximum frequency content of xt. So if you want to sample this signal, this component is of 3 Hz, omega equal to 6 pi, and here omega equal to 4 pi, so its frequency is 4 Hz. So the maximum frequency content in xt is 4 Hz and yt is a scaled version of xt. Okay, yt is, you have the scaling factor is 2. So the frequency of yt will be 2 times frequency of xt. So in xt the maximum frequency content is 4 Hz. So in yt the maximum frequency content will be 8 Hz. So Nyquist sampling rate for yt will be 2 into the maximum frequency content, that is 8 Hz. So Nyquist sampling frequency will be 16 Hz. C option will be correct. Okay, here xt is given as sin t divided by convolution. This is convolution. Sin t divided by pi t, convolution sin t divided by pi t. Basically we have to calculate this convolution. Okay, so finding out convolution in time domain of this signal will be difficult, so better to convert. Let's say this is yt, so we have to find out yt convolution yt, and this is xt. So what will be xs? Xs will be ys into ys. So first we will find out the Laplace of yt, that is ys. We have to find out Laplace of sin t divided by, or Laplace or the Fourier of yj omega into yj omega. Laplace or Fourier transform of yj omega. If xt is yt convolution yt, xj omega will be equal to yj omega into yj omega. So first we have to find out yj omega, the Fourier transform of sin t divided by pi t. Okay, so we will find out the Fourier transform with the help of duality theorem. We know that if we have a rect function in time domain starting from minus k to plus k and height is 1, Fourier transform of this time domain signal is this is 2 sin k omega by omega. And using duality theorem, if you have this kind of function in time domain, that function is, let's say this is xt and this is capital X omega. Now you have capital xt here. So for capital xt, the Fourier transform will be small x minus omega. And since small x is an even function, the duality theorem says if a small xt has a Fourier transform capital X, then with the help of duality theorem, the capital X will have a Fourier transform equal to a small x function with a multiplication of 2 pi, and here you will have minus omega. Now a small x is an even function, so 2 pi x minus omega will be 2 pi x omega. Capital xt will be, capital X is this type of function, so 2 sin k, at the place of omega we will have t here, 2 sin kt divided by t, its Fourier transform will be x omega. This is xt. On x axis we have t. Here we have x omega. So on x axis we will have omega. So x omega will be minus k2 plus k, and height will be 2 pi times xt. So here you will have 2 pi. So this way, with the help of duality, we found out the Fourier transform of 2 sin kt divided by t, and we have to find out Fourier transform of sin t divided by pi t. So we have to divide this function by 2 pi. So if you will divide it by 2 pi, then you will get minus k2 plus k, and height will be 1. So this is nothing but, this is yj omega. Yj omega has height 1, and it is starting from minus k radian per second to plus k radian per second. So what will be yj omega into yj omega? If you will multiply the same function, this will be yj omega whole square. So when you will do 0 square, you will get 0, and 1 square is 1. So basically you will get the same function yj omega, and yj omega is nothing but xj omega. So xj omega is equal to yj omega. Now if you will take inverse Fourier transform, you will get xt will be equal to yt. And what is yt? Yt is sin t divided by pi t. So xt will again be sin t divided by pi t. The option will be correct. In this question, xn is given and yz is x of minus z. Then we have to find out yn. So if xn is given, first find out xz. What will be xz? Formula for xz is summation xn z to power minus n varying from minus infinity to plus infinity. But this will give value at n equal to 3, and the another non-zero value will be at n equal to 5. So when you will put n equal to 3, the value is 1, and at n equal to 3 you will get z to power minus 3 plus z to power minus 5. This is xz. Now yz is x of minus z. So this will be minus z to power minus 3 plus minus z to power minus 5. This will give you minus z to power minus 3 minus z to power minus 5, and this is nothing but minus of xz. Yz is. So when you will take inverse z transform, yn will be equal to minus of xn. C option will be correct. In this question, we have a system with transfer function hs equal to e to power s plus e to power minus s, and to this system the input is 2 cos 2 pi by 3t plus minus cos pi t. The input is composed of two sinusoidal signal. The frequency of this signal is 3 by the frequency of this signal is 1 by 3 hertz, and here frequency is 1 by 2 hertz. Okay. So, and then we have to find out, there will be some output, and if Ck denotes the kth coefficient in the exponential Fourier series of the output signal, if the output signal is represented in the form of exponential Fourier series, then what will be the value of C3? So if C3 is the coefficient, then this will be C3 into e to power j k, k is 3 omega naught t. Okay. The term with C3 will be C3 into e to power j, at the place of k will have 3, and omega naught is will be fundamental frequency of output. So let us first find out what will be the output when the system transfer function is given as this. Now we know that to an LTI system, this is an LTI system, okay, if output is for any LTI system with transfer function Hs, if you will give an input sin t, the output will be H, or sin omega naught t, the output will be value of Hj omega at omega equal to omega naught into sin omega naught t, or this output can also be written as modulus of Hj omega naught sin omega naught t plus phi, where phi will be the angle of Hj omega at omega equal to omega naught. Okay, so let us first find out Hj omega. Hj omega will be e to power j omega plus e to power minus j omega, and this will give you 2 cos omega. So the system is okay. Now the input is composed of 2 frequencies, or the input is composed of 2 input signal, and since the system is linear, so the output will be, how we will find out output? We will individually find out output due to each input signal, and then we will add those 2 outputs. What will be output due to the first signal? Output due to first signal, let's say this is V01, this will be 2 cos 2 pi by 3t into value of Hj omega, this is value of Hj omega at omega equal to omega naught, where omega naught is source frequency. So source frequency is 2 pi by 3 here. So this will be value of Hj omega is 2 cos omega, and at the place of omega we will have omega naught, and omega naught is 2 pi by 3t. So this is 2 pi by 3t, and V02, the second output will be, the total output will be V01 plus V02. This is minus cos pi t into Hj omega. So here we will have 2 cos, and at the place of omega naught we have pi. This t will not appear here. So the total output will be, this is a constant, cos 2 pi by 3 this will be minus 1 by 2, and into 2 will be minus 1, so V0 will be minus 2 cos 2 pi by 3t minus cos pi is minus 1, so minus minus plus 2 cos pi t. Okay, so this is the output. Now we have to represent this output as in the form of exponential Fourier series. Okay. So first we will have to find out the fundamental frequency. What will be the fundamental frequency? Each frequency component will be an integral multiple of fundamental frequency. Let's say 2 pi by 3 is a fundamental frequency. If 2 pi by 3 is a fundamental frequency, the pi has to be an integral multiple of 2 pi by 3. If it is a harmonic, if it is a fundamental frequency, so pi has to be an integral multiple of 2 pi by 3, and pi cannot be integral multiple, so 2 pi by 3 cannot be fundamental component. So to find out fundamental component, we will take HCF of all the frequencies 2 pi by 3 and pi, and HCF will be pi by 3. So pi by 3 is nothing but omega naught. So V naught will be minus 2 cos 2 omega naught t, this is second harmonic, plus 2 cos, pi can be written as 3 into pi by 3, and pi by 3 is omega naught, so this is 3 omega naught t. So this is second harmonic and this is third harmonic. Now we have to represent it in exponential form. So this will be minus 2 into e to power j2 omega naught t plus e to power minus j2 omega naught t by 2 plus 2 into e to power j3 omega naught t plus e to power minus j3 omega naught t divided by 2. So V naught will be minus e to power j 2 omega naught t minus e to power minus j2 omega naught t, okay, plus e to power j 3 omega naught t plus e to power minus j 3 omega naught t. And V naught has to be represented as Ck into e to power j k omega naught t. So here you have k, in this term you have k equal to 2, so the here coefficient will be C2 will be minus 1. Here at the place of k you have minus 2, so here the coefficient will be C minus 2, this is equal to minus 1. Similarly here k is equal to 3, so this will give you C3, and here the coefficient is 1, so the value of C3 will be 1. Okay, we are given with a signal xn equal to 2 to power mod n, and for this signal we have to find out the region of convergence. We are given with a discrete time signal, and while calculating its z transform xz, we have to find out region of convergence for which the z transform will exist. In the first option it says the region of convergence should be inside circle mod z equal to 0.5. So in equation we will represent the region of convergence will be mod z less than 0.5. Here the region of convergence is, this is mod z equal to 2, mod z must be greater than 2. Here the region of convergence is between mod z equal to 0.5 to mod z equal to 2. Mod z has to be greater than 0.5 and less than 2. And D option says ROC will not exist for this type of signal. Okay, when we studied xn equal to a to power, you would have done this type of example. In each book this type of example is given. right after the theory of Z transform, the first example will be a to power n un, then the next example may be a to power n u minus n, okay, and the third or fourth example will be xn equal to a to power mod n un, and you have to find out Z transform of this signal and region of convergence. For this type of signal, the region of convergence is mod z has to be greater than mod a and less than 1 upon mod a, okay, and the region of convergence must satisfy this condition, and for this condition to be valid, mod a must be less than 1 upon mod a, because mod z is greater than mod a and mod z is less than 1 upon mod a. So this quantity is greatest, this is the least. So least quantity has to be less than the greatest quantity, and for this a square has to be less than 1 or modulus of a has to be less than 1. But in this question, at the place of a we have 2, so modulus of a is equal to 2, which is not less than 1. This is not less than 1. Okay, so for this type of discrete time signal, ROC will not exist. This is the general formula for finding out ROC for this type of signal. If you will put a equal to 2, mod z has to be greater than 2 and less than 1 by 2. These two conditions cannot exist simultaneously. If mod z is greater than 2, it has to be greater than 1 by 2 also. Okay, so for this signal, ROC Z transform will not exist. The option will be correct. If any signal, if you will plot the graph of, in the lecture I have discussed it, xn versus n, and xn is 2 to power mod n. The graph will look like this. I am plotting the, this is not a continuous signal, so I should not draw continuous graph, but I am just plotting the boundaries of those signals, those values. Values will be like this. So if a signal is increasing and it is going to infinity to both sides, the ROC for this type of signal, the Z transform for this type of signal will not exist. This will not exist, or there will be no ROC. Okay. If a signal exists only in one side, if it is increasing only in one direction, it is going to infinity, so here ROC may exist. Or if the same signal is increasing to left direction only, and it is also not necessary that it has to start from 0 only, it may start from here, okay, or the signal may be like this, it is decaying in one direction and increasing in, okay, let us not take this example. If signal is increasing only in one direction, then for this type of signal also ROC will exist. Another way of finding out ROC is, let us try to find out Z transform of this signal. So Z transform is xn z to power minus n is varying from minus infinity to plus infinity. Okay, so xz will be two to power mod n minus infinity to plus infinity and z to power minus n. Okay, and mod n has two values and the boundary is at 0, so let us break this summation at n equal to 0. This will be minus infinity to minus 1, and when n is negative, value of mod n is minus n, plus minus 1 is done here, so next we will start from 0 to n, and from 0 to n is positive, so mod n will be equal to n, 2 to power n z to power minus n. Okay. So we have two series and both the series has to converge. Here we have n is varying from minus infinity to minus 1. We have 2z to power minus 1 minus n plus, here we have 2 divided by z to power n, and n is varying from 0 to infinity. If you will open this series, let us first put n equal to minus 1. So we'll have 2z. When n equal to minus 2, you will get 2z square plus 2z to power cube and so on. And in the second series you will get, if you will put n equal to 0, you will get 1, then 2 by z plus 2 by z whole square, and both are in finite series. Okay. Here common ratio is r equal to 2z, and here common ratio is 2 by z, and both the common ratios have to be less than 1. So here mod of 2z has to be less than 1, it means mod of z has to be less than 1 by 2, and here mod of 2 by z has to be less than 1, it means mod of z has to be greater than 2. Okay, and it is for z transform to exist, it is necessary that both the series has to converge simultaneously. So for this series to converge, mod z has to be less than 1 by 2, and if mod z is less than 1 by 2, mod z cannot be greater than 2. So when this series converges, this series will not converge, and if the second series converges, the first series will not converge, and this way you will not get any ROC. You will get no ROC for the convergence of Z transform.